Okay, this is the Professor, CBMD PhD, and today's Thursday, June 29th, 2023. It is 10:49 and 24 seconds, p.m. Eastern Standard Time, and today's research, Cosmic Web. So let's hop to it here. Earliest strands of the Cosmic Web, date June 29th, 2023. Source, NASA Goddard, Space Flight Center. Galaxies are not scattered randomly across the universe. They gather together, not only into clusters, but into vast interconnected, filamentary structures, with gigantic, barren voids in between. This cosmic web started out as tenuous and became more distant over time as gravity drew matter together. Astronomers discovered a thread-like arrangement of 10 galaxies that existed just 830 billion years after the Big Bang. The 3 million light-year long structure is anchored by a luminous quasar, a galaxy with an active, supermassive black hole at its core. The team believes the filament will eventually evolve into a massive cluster of galaxies, much like a well-known coma cluster in the nearby universe. They were surprised by how long and how narrow this filament is. They expected to find something, but they didn't expect such a long, distinctly thin structure. The main goal is to study the cosmic environments of the earliest black holes. In total, the program will observe 25 quasars that existed within the first billion years after the Big Bang, a time known as the epoch reionization. The last 2 decades of cosmology research have given us a robust understanding of how the cosmic web forms and evolves. Astronomers aim to understand how to incorporate the emergence of the earliest massive black holes into the current story of the formation of the cosmic structure. Another part of the study investigates the properties of 8 quasars in the young universe. The team confirmed that their central black holes, which existed less than a billion years after the Big Bang, range in mass from 600 billion to 2 billion times the mass of our Sun. Astronomers continue seeking evidence to explain how these black holes can grow so large so fast. And to form these supermassive black holes in such a short time, 2 criteria must be satisfied. First, you need to start going from a massive seed black hole. And second, even if the seed starts with a mass equivalent to 1,000 suns, it still needs to accrete 1,000,000 times more matter at a maximum possible rate for its entire lifetime. These unprecedented observations are providing important clues about how black holes are assembled. We have learned that these black holes are situated in massive young galaxies that provide the reservoir of fuel for their growth. Webb also provided the best evidence yet of how early supermassive black holes potentially regulate the formation of stars in their galaxies. While supermassive black holes accrete matter, they also can power tremendous outflows of material. These winds can extend far beyond the black hole itself on the galactic scale and can have a significant impact on the formation of stars. As strong winds from black holes can suppress the formation of stars in the host galaxy, such winds have been observed in the nearby universe, but have never been directly observed in the epoch reionization. The scale of the wind is related to the structure of the quasar, and the Webb observations they are seeing that such winds existed in the early universe. And this is a Professor of Astronomy, Space Technology, Advanced Physics, and Leader of Research. This video was created for educational purposes only. Hope you enjoy listening. Until next time, have a great day.